Hello, welcome back to Blender Sushi Live Noding. In this episode, we're gonna continue a little bit from where I left off. It's this one, SV Sverchok Scales Intermediate. There's one more thing I like to add for this guy, so I'm just gonna grab this zip and continue from there. So I already have Sverchok installed, so I can just hit space and then tap zip and then load the zip. So this will load it from GitHub and wait a few seconds and we should have the setup for us. So last time we were up to here. Let's save it real quick to SV Scales Advanced 001. And this guy, we're gonna find the source. Okay, this guy, the sphere. We can replace it with anything, cylinder, icosphere. We're not gonna do that. I'm gonna just use a plane and plug in the vertices, edges, and polygon. And you can see the result. Let's increase this so you can see what's going on. Oh yeah, the scale is actually quite large. I think the leaves or the scales need to be smaller at some point, or you can change it yourself. But anyhow, the grid, it's kind of doing that, and you can control the rotations like that. If you want to maybe tile it for a rooftop or something, you can always replace this element for tiling. But there is one little problem is that, let's say we have like Suzanne, and if this guy is really just tiling the objects based on the polygon face, Suzanne face, for example, around the face is like a little bit like small, around the mouth a little bit small. Everything else, it's gonna be like larger. It's not gonna look nice. So how do we go around this problem? First of all, we know a trick, a dual mesh trick from these tissue tools. I really like this one. I just wish this can be a node. You can kind of trick it in Sverchok, but I'm just gonna use this. So yeah, with the dual mesh, we kind of have this like this kind of fake Voronoi. Actually, with a plane as well, you can do that. If I bake the plane, and it's gonna become like a hexagonal. So, but that's not what we want either. At least not the first step. The first step is actually to use a mesh remesh modifier. So this guy, remesh, of course, if you turn it into, let's say, like a block, the voxel is actually equally spaced. So let's say for Suzanne head, this thing will be good if you watch. Just imagine all the points around the voxel. That can be like a kind of projected into Suzanne back. Let's say I'm used like a smooth, and this guy also pretty good because all the vertices here is pretty much equal around it. So let me try smooth it beforehand. So I smooth it beforehand, and then I did a remesh. I'm just gonna work with a level 5 here, like this. And remove disconnected, doesn't matter for now. Maybe go up a little bit more. So this is a little bit high. Go down, adjust this. Okay. Okay, this looks pretty good. So I'm gonna duplicate it, and we're gonna bake this. Apply and apply, so we get this Suzanne. And if we want to tile all this stuff into Suzanne head now, we have like more or less like equally spaced points or the polygons. So, and then even better is that we can use the tissue add-on dual mesh now. And we're gonna get this pattern, and this pattern of course is a hexagonal, and it looks really good now. It's like equally spaced almost, and yeah, and we can use this for our template. So let's save this, save again. I always do that. And replace this guy, cut it, objects in, get Suzanne, plug this in, vertices, edges, polygons, and wait for a bit. Oh, okay, it's sort of working, but I think I need to increase the number maybe. Matrix in. Actually, we need to use matrix apply because this Suzanne already have transformations, right? So vertices and the transformations, it's like apply a transform, and then the point is now updated. Now we have Suzanne with all this scale. And the next thing we can do is to maybe we need to resize Suzanne, but we can control this guy right here, the scale. Okay, now Suzanne is now covered in scale. Of course, this there's like more there's like tricky part is like to control the rotation of the scale properly. You know, like would be nice to be able to just kind of flatten this scale along the surface. I don't know how to do that yet. Let's see. This is the objects that's being instanced. So that's the rotations, controlling all the rotations. And I actually forgot one thing here. Instead of rotating the scale here on Suzanne, I'm gonna scale it further. So yeah, it looks like this at the moment. This is like the actual the scale all being controlled using this value. This is for all the scale, which is the actual objects. What we really want is just to actually use matrix deform, and we can do the angle here, the angle thing over here. So polar output, I think we can add another rotation here. I'm not sure with which rotation, maybe the Z, save, and float. So this part is very important. This allows you to control the rotations for each and every scale individually. Okay, that's what I try to do here. Not 001. I think it's 0100 maybe in the x-axis, and this should control the flipping. Hopefully, no. Apparently, this is also wrong. Let me try again. So that seems to be controlling the twist. So it's probably 0010. And let's see. Now I think okay, I think this is the best setup here. So I think this is correct. So we are controlling the flip. I think the best scenario is really to have the scale follow the surface somehow, and there is some kind of up vector and things like that. That's probably like an extra, just a little bit of modifications. I don't know, maybe you know it, how to do it. Let me know, please, because it's get pretty technical, but at least we cover like some of these situations. We can do the flip of this scale. So ups and down for all the scale part, and we can randomize it. So if we use like range, let's just use random number for the flip, and I don't know what's the angle. It's probably between so the up vector is like -45, and then how about when it's down? When it's down, it's maybe 45. Okay, so -45 and 45, and we plug this into the angle, and it's gonna vectorize. Let's give it a, how many do we have? Okay, 1662, not too much, not too bad, this number. And now we can have like randomized scale on Suzanne. And this actually, if you have like, if you increase the resolutions, if you subdivide this hexagon, it's gonna start to look like a fur, you know, like a bird feather. I think this is really cool setup right here. The number of matrices should match. So I think list length, and this guy should go in there if you want to randomize, if you want to increase the number of Suzanne resolutions in order to get the correct total value of the matrix. Level 0. Okay, this goes in here. So this level thing in Sverchok, be careful. All right, we can scale Suzanne. Now it start to get crop. We need to increase this value 2500. So now it's sort of okay. Subdivide it and turn on post modifier, and it's gonna increase the resolution 4 times. We're gonna have 4 times the number of the scale, or now it's like a feather. And Suzanne, the topology also changes, and it's gonna look much more dense, of course. Hopefully my computer can handle it. But that's basically the setup. I hope I saved it because it might crash. Okay, it works. Cool. Cool, it works. And here, actually, have we joined it? We actually didn't join it. We actually should join the whole thing at the back here. If you want it as a single mesh, don't bake 10,000 objects. It's gonna crash Blender. So you need to mesh join or apply matrix. Pick the second one. And for all these almost 10,000 matrix transforms, we're gonna combine all the instance of these leaves or the scales. I think the scale itself can be actually, you can kind of procedurally generate it, like using just shader. Definitely, and it's actually not that complicated. After you've done something like this and you want to convert it to shader, okay, apparently you can just use the face. Hexagonal face is good. Polygon face, that's if it's like equally distributed over 3D objects, you can turn that into a scale. Oh, okay, it's doing the calculation again. It's I need to stop the calculations before I'm doing this. So turn off processing. So I need to just pipe this guy in there, cut this. This goes in there, this goes in there. So this already join everything, and save. Turn on this and do one more calculations, and we are done. Oh yeah, if you see, if you have a hexagon and then you subdivide it one time, it's gonna become like this kind of flowery pattern, which is pretty cool. I always like the tiling of topology. It's very interesting subjects here. Okay, it's calculating. Hopefully it doesn't crash. Should be working. think from here, the next step will be like if we can simulate the whole thing using particles. So if I just bake this, it should generate the objects for us. So this guy. So we have this Suzanne. What is it? Okay, that's that guy. But here, so that's the results. It's like a feather, and we can make it like this and give it a max cut. There you go, like a Suzanne feather. So that's the whole process. Basically, remesh to get equally spaced points along to cover the surface of Suzanne. This one is subdivided ones, and this is just a preview of the edges, and this is the result. Okay, hopefully you find this useful. If you have any question or feedbacks, let me know in the comments section below, and thanks again for tuning in. I'll see you next time. Thank you. Bye.